Hello, everyone. Today, we're going to upload a previously created MetaHuman character to MetaHuman Creator using the newest method. If the MetaHuman Creator plugin is enabled in your engine, you should be able to right-click and find the MetaHuman category, where you can create an asset called MetaHumanCharacter. This asset file is what we refer to as the MetaHuman Creator asset. From the Preset tab, you can select a template and modify individual parts through blending, just like this. And if you move over to the Materials section, you can apply the skin you want. Now we're going to apply the cartoon character we created into this system. First, go to the Body section and click the Conform button. Then, click from Template. After applying it to our character, click Import. All right, it looks like the body has been imported correctly. Now let's go to the Head section and apply the cartoon head in the same way. You can see several options here for importing the head. Let's try importing it as is for now. The neck looks really weird, doesn't it? Set the alignment option to none and uncheck Adapt Neck. Then try importing it again. It should load in correctly now. Everyone, you may have noticed the Import DNA button over there, but don't rush to use it just yet. There are still a few things we need to take care of before we can properly upload our character to MetaHuman Creator. Let's go back to the Body section and open the Blend tab. Try picking any 3 characters and blending the arm. Do you see how strangely it's blending? This also happens with the legs, although it's a bit less noticeable there. But especially with the arms, the blending looks really off. Why is this happening? The reason lies in the difference in joint angles. All MetaHuman body presets maintain a consistent joint angle. However, our custom-created character has a completely different joint orientation due to its unique shape. In other words, if we want to make our own character preset compatible with MetaHuman Creator, we need to match our character's joint angles to those used in standard metahumans. To align our character's joint angles with the standard metahumans, we need to use the MetaHuman template from the MetaHuman Set tool. Now, we'll use the Body Angle Set function to save the joint angles from this template. In fact, this feature was also introduced in the TunaMetaPack 1.3 update. From this state, click the Save button, then give the file a new name, and save it to the folder path that appears. You'll now see the saved angle appear here. Next, go back to your character rig, open MetaHuman Set again, and apply the body angle you just saved. But, as mentioned in the 1.3 update patch notes, the clavicle joints should be excluded when applying the angle. Click the Select Main Driver Joint button, and make sure to deselect the clavicle joints before applying it. This prevents the shoulder shape from collapsing. As you can see here, you must exclude the clavicles before applying the angles. Once applied, your character's pose should now match the original MetaHuman angles. If your character's spine or other areas appear distorted, make sure to also exclude those joints during application. Now that the joint angles have been modified, we need to save this new state back into the body DNA, right? Open the DNA editor and set a new path to save the updated DNA file. Next, go to the Geometry tab, and we need to save the joint data as it is in the current initial pose. Click the Break Joint Connections button, and then save everything, including the geometry information just as it is. Why? Because when the joint angles change, the body mesh shape also changed accordingly. Now, all the LODs of the body mesh should have been saved in this updated form into the DNA file. The main joints responsible for each part of the body should now have their rotate values reset to 0. And this doesn't apply to just the body. The head has also been updated in a similar way. So we also need to save a new head DNA that reflects these changes, and open the DNA editor again. This time, load the head DNA. Now, save the head DNA the same way you saved the body DNA earlier. But, as I mentioned in a previous session, when saving the head DNA, you must move spine 4 out of the hierarchy before saving. This is because even though spine 4 is the root joint in the DNA, it still contains local space coordinate values. So you must unparent it first to convert its position to world space, and then proceed with saving. Just like before, break the connections and save everything, including the geometry information. Oh, and one more thing. Before saving, it's highly recommended to turn on visibility for all LOD meshes. Sometimes in Maya, if a mesh is not visible, it might not get processed properly, and the data may not update correctly. To avoid this, make sure all LOD meshes are visible when saving the DNA. It's a much safer practice. The body and head meshes here are already in a moved state from their original bind pose when the skinning was first applied. We can't export them like this. For export to the engine, the initial bind pose and the skinning data must match. That's why I'm going to completely reload the DNA using the Characator Assembler. Make sure to check both head and body, and then proceed to load. In my case, I had already overwritten the head and body DNAs into the Ada template, so I can load directly from there. But for you, if your DNA files are located elsewhere, you'll need to overwrite your updated DNA onto the Ada template DNA before proceeding. Now, technically, even if you don't reimport with the Characator Assembler, you could still bring the skeletal mesh into Unreal Engine 5 by checking the Use T0 as Ref Pose option when importing. That would import the mesh based on its final pose state. However, importing based on the original bind pose is much safer, so I'm choosing to rebuild the rig completely using the Characator Assembler. Alright, everything is now loaded correctly. But, as mentioned previously, importing through the Characator Assembler causes seam lines to appear. That's why you need to replace the current mesh with the previously created LOD meshes that didn't have those seam lines. However, the current character is in a different pose than those LOD meshes. So, we'll need to copy the meshes from our rigging file and use those to do the replacement. Let's temporarily bring in the rigging file as a reference. With a namespace applied, I forgot to save earlier. No worries. In this kind of situation, all we need to do is match the joint angles of the original rigging file to the ones in our current character. So, how do we apply the same joint transforms to the rigging file we just referenced? It's actually very simple. First, open TunaUtils. There's a newly added feature called Match Matrix to Replaced Objects. This feature allows you to apply the same matrix transform from a set of source objects to a different set of scene objects that have matching names but with name replacements, such as different namespaces. In this case, the joints I've selected have namespaces attached, and these joints will act as targets, not sources. In the current scene, we also have a version of these joints without any namespaces, which will act as the source. So first, I'll enter the namespace string into the search field. Then I'll leave the replace field blank. This way, it can find the matching joints without namespaces in the scene. I'll also uncheck the Search is Source option. That's because the joints with the namespace are not the source, but the target. The joints without namespaces will be treated as the source transforms. Now, select all the joints with namespaces the targets, and set the type to Joint since we only want to apply transforms to joints. Once you click Execute, you'll see that it finds the matching joints without namespaces, copies their transforms, and applies them directly to the joints with namespaces that you selected. At first, this may seem like a complex process, but if you're familiar with the search and replace concept, this tool is actually very simple and powerful. Now I'm going to copy the body mesh and head mesh here for replacement purposes. We no longer need the original rig file, so let's remove the reference. In the head group, I'll keep only the head mesh and delete the other objects. Alright, the shaders are gone, but that's fine. We now have properly shaped meshes with correct seam line normals. Now it's time to replace the meshes. Inside TunaUtils, I'll use the Auto-Match Selected Mesh to All Scene Mesh function under MetaHumanUtils. First, I'll turn on visibility for all LOD layers. If this is too much trouble, You can just delete the layers to simplify these things. Using the selected meshes, this tool will automatically replace all scene meshes that share the same vertex count meshes. You'll now see that all the seam lines are cleanly removed. Meshes created as backup data can be deleted, and every meshes has been replaced with the correct smooth seamline meshes. As you can see, everything has been cleanly replaced, and the seam lines are now completely gone. Now, let's apply the materials. We'll quickly apply them by loading the template from Meshwarp. I'll apply the materials not only to the head, but also to the body. The template meshes we loaded earlier is no longer need. Whenever you delete something, make sure to clean up the scene. Getting rid of unnecessary nodes should become a habit. Now it's time to apply the LOD group, right? Yes, if you check the skinning now, you can clearly see that the current state is the bind pose. Of course, we could have just new bind the skin weights from the previous rig file and applied skinning data to them again. But I wanted to show it more clearly for you guys, so I re-imported the DNA file itself using the Characator Assembler in this tutorials. Please prepare the rig manager. All right, let's proceed with the proper export now. Select the entire rig group and apply the head export set. From here, select the entire hierarchy including the root and the LOD group, and export it using the game exporter. Let me quickly change the viewport color values. This time, I'll add MH to the name. As I mentioned before, to avoid confusion, in my case, any metahuman used in the MetaHuman Creator will have MH added to its name. Select the entire hierarchy and export it. Now let's select the root joint and rig group, which have been separated again, along with the entire hierarchy, and reassign the hierarchy structure using the body export set, just like before. Select the entire hierarchy, including the root and the LOD group, and export it using the game exporter. Now I'll restore the original hierarchy structure. All right, let's move on to the engine and create a dedicated folder for the MetaHuman Creator version of the character. This one will be called Cartoon MH. I'll move the MetaHumanCharacter asset file that was in the original cartoon folder into the Cartoon MH folder. Now let's import the recently exported pose corrected body and head FBX files as skeletal meshes here. First, as mentioned last time, the head skeleton must always be the face archetype located in the common folder inside the MetaHuman folder. I don't need the physics asset, so I'll delete that. As for the body, it should also use the MetaHuman base skeleton found in the common folder. Now let's open the MetaHumanCharacter asset file. Should we start with the head? Normally it's better to replace the body first, but let's try the head for now. I'll keep the settings the same and import it directly. Oh, something got applied, but now there's a gap. Let's apply the body as well. Let's now apply the MH body we just imported. with the corrected pose and import it as is. Oh no, see, this is exactly why I said the body should be done first. Once you apply the body, the head always breaks again, so you'll need to reapply the head afterward. Now that we've reapplied it, everything looks fine. Always remember, body comes first. All right, now that our character's joint angles roughly match the MetaHuman presets, let's test if the blending works well. But before that, we need to load the DNA file for the head. Select our DNA file, but do not click the import button just yet. If you click that now, the rig process will begin, and we only want that to happen at the very end. So, for now, do the same for the body. Assign the DNA file, but don't click import button yet. Currently, MetaHuman Creator only supports applying a DNA file to either the body or the head, not both. Let me explain that in more detail. The character we brought into MetaHuman Creator has completely different joint transforms compared to the ones we created earlier. As soon as you bring the mesh into MetaHuman Creator like this, even if it uses the same mesh, it's essentially regenerated with entirely different joint transforms. And once you import the DNA here, it locks the setup. You can't make further changes. That's why I mentioned earlier that only one DNA, either body or head, can be used. For now, let's move on and test the blend feature. Go to the body blend section. Pick any 3 characters and blend the arms. Do you see how different it is from the first time I showed you? The blending is now working very nicely. The legs are much better too. Oh, even the head size blends properly now. Now let's import the head DNA file using import whole rig. When you do this, the head DNA gets loaded and the rig for the current character will be processed. As you can see here, there's a noticeable gap between the head and body after the rig is completed. Earlier, we modified the body using the blend function, right? So what's happening here is the body shape was changed because of the blend function, but we're importing the head DNA as is, so this kind of mismatch occurs. First, let's use the Remove Rig option at the top to clear the current rig. Then let's reload the body geometry. We'll do the same for the head geometry. Reload it as well. Now, in this state, let's try importing the head DNA again, using Import Whole Rig. Yes, now it looks correct. So far, we've only imported the head DNA and not the body DNA. This is currently the only way to make things work properly inside MetaHuman Creator. Since the head DNA has been loaded, the animation, including all the facial movement designs we created earlier, should now appear correctly. Let's try applying a different animation. Of course, you can also skip importing DNA and just use the Create Full Rig option here to proceed with rigging right away. However, that approach doesn't guarantee facial animation will work properly. Also, we deliberately didn't apply DNA to the body, which means the current body isn't using the DNA we made. Unfortunately, this is something we can't really avoid right now. Epic Games hasn't fully supported customizing body DNA yet, so there are still several bugs and limitations. At least the head DNA appears to be working well. It's showing up correctly. For now, I'll remove the rig again and try adding some hair or other elements. Then I'll reapply the head DNA rig. Looks good. Now, let's move over to the Assembler tab and export to UE Cine. If you also need this character inside Maya, feel free to export it to DCC if you need. I'll name it the same, Cartoon MH. Let's download the textures first, and then run the assemble. You can now see that a brand new MetaHuman character has been created inside the Cartoon MH folder. The character blueprint has also been exported properly. Let's create a level sequencer and test things out. As we design, the face is reading the DNA correctly and working beautifully. Since the body DNA wasn't applied, it's most likely using a temporary auto-generated DNA internally. Still, since the joint angles match, it seems to function pretty well. Our cartoon character's signature smile still shows up nicely. You can also register this MetaHuman character asset you've created as a preset for reuse. If you go to the optional preset folder inside the MetaHuman Creator directory, you'll find presets for MetaHuman characters. Simply place your asset file in there. Now, let me explain why you shouldn't use body DNA and what kinds of issues can arise. Let's say you assign the body DNA path and try to import it using whole rig. The moment the body DNA is imported as a whole rig, do you see how the body normals get completely distorted? This actually comes from Ada's normal data. We never save normal information into our own DNA, right? As a result, you'll see visible seam lines here. Now let's say we overlook that for a moment. The real issue lies elsewhere. What happens if we now import the head DNA using whole rig in this state? As I mentioned before, once you import head DNA as a whole rig, the MetaHuman rigging process locks it, and you can't modify it further. And as you can see, we again get a noticeable gap between the head and body. The head is correctly rigged using DNA, but the problem is with the body. When the rig is applied to the body, it automatically scales up to match the head, resulting in a persistent mismatch. Animations may still work to some extent, but the gap becomes too large to ignore, which is why I strongly advised against using body DNA in MetaHuman Creator. If we use remove rig, the gap disappears again. The only real fix is to avoid using whole rig for the body. And actually, I forgot to mention earlier, you don't even need to select a skeletal mesh to bring in the mesh using DNA. You can directly load the mesh using the DNA file alone. If you import the body using DNA but not whole rig, the normals get recalculated and they appear correctly. And just to clarify, you can still use head DNA. As long as you only import the head DNA using whole rig, everything will work as expected. So then, does that mean you can't use body DNA at all? No, not at all. You can use it. If you previously created a character blueprint using MetaHuman AutoSet Newest, that setup actually allows you to use both your original head and body DNA, and in the latest compatible DNA format. In any case, that character blueprint represents your character in its true form, and you can freely use both the head and body DNA files that you designed. The only time we advise giving up on body DNA, as shown in this tutorial, is when you want to bring your character into MetaHuman Creator. In that case, we temporarily adjust the body joint angles to match existing presets and hold off on applying the body DNA. But since you've already saved your cartoon MH as a preset, now when you create a new MetaHuman character asset, you can use that preset as a base. You see it showing up here under the preset list, right? Let's try blending with cartoon MH. As you can see here, once you've saved your original character as a preset, you can now blend with it. You don't start blending right away. You first save it as a preset, and then use it when you're creating new characters. It's the same for the body. If you want to create a certain cartoon style, make the cartoon preset first, and then proceed with the setup, just like we're doing now. No matter what kind of character you want to create, as long as it's properly set up, you'll be able to use it seamlessly in MetaHuman Creator. Always remember, proper character setup is the most important step of all. So, is it starting to feel more like a cartoon style now? Now, let's try doing a create full rig with this version. Since this one doesn't have DNA, we'll have to rely on MetaHuman Creator to handle the rigging. This character is like a descendant of the cartoon MH version. And if you're not satisfied with how the rig turns out, you can always export it to DCC, bring it into Maya, and modify it using TunaMetaPack. At this point, I believe you now understand the overall pipeline structure for working with MetaHuman characters, how to approach it, and how to build your characters properly. That wraps up this MetaHuman Creator tutorial. Thank you so much for watching until the very end.